Video, we're going to be talking about graphs of tangent functions. In the next video, I'll talk about reciprocal functions. So I'll break this up into two parts here. To start off with, we need our definition of tangent. Remember that tangent is opposite over adjacent, which we redefined as y over x. Y values or y coordinates are given to us through sine functions. X coordinates are given to us through cosine functions. So another identity we can use is sine over cosine. We'll use that identity a little later, so I wanted to bring it up here. Either way you think about it though, if we have a ratio, we know that the bottom cannot be 0, otherwise we have an undefined value. So in the tangent case, tangent ratio, if x is 0, then tangent is undefined. So if we think about the unit circle, where do we have x values that are 0, or where is our cosine function 0? We know that if we don't go left or right on the x-axis, if we are on the y-axis, our x values are 0. So tangent is going to be undefined when we evaluate angles that get us on the y-axis. That happens at pi over 2. It also happens at 3 pi over 2. But really it would happen at any interval, no matter how many times we rotate, if we end up on the y-axis. So what we can do is we can define that as saying whenever x is equal to pi over 2 plus any interval of pi, we're always going to end up on the y-axis. So for example, if my interval is 0 right here, that n value, then x is pi over 2 and I'm undefined. If n is 1, then I'm adding pi. So pi over 2 plus pi gets me to 3 pi over 2. So now I'm back on the y-axis again. So anytime I take my starting point and I add pi to it, I'm going to get to a vertical asymptote, an undefined value on a tangent graph. So when we graph, we're going to see vertical asymptotes or undefined values. Also, when we look at this, we can see that we can only go a pi rotation here. So the period length of our graph is just going to be pi, different from sine and cosine, which was 2 pi. Let's see an example of that when we graph it down here. We can investigate this using our calculator. Make sure that your calculator is in radian mode. We're going to be plugging in some radian angle measures here. Test your calculator out. If you ask it to evaluate tangent of negative pi over 2, it should tell you error or undefined. The value of pi over 2 is actually 1.57, and then it doesn't repeat. It's irrational. It goes on forever. So if we just move to the right of that value, if we just do negative 1.57, so just barely to the right on the x-axis, we can actually start to evaluate that value. So the tangent of negative 1.57 gives us this very large negative y value, meaning that we are way far down on the y-axis. Again, if I just slide just a tiny bit to the right again on the x-axis and evaluate tan of negative 1.5, our calculator will tell us it's negative 14.1. So notice the difference there. I barely moved on the x-axis and I moved a heck of a lot on the y-axis. So our graph is pretty steep. One more time. Negative pi over 4. Let's evaluate that. We actually don't need our calculator for that. We know that if the coordinates of pi over 4 are the same, square root of 2 over 2, then when I plug that into my ratio and I divide my coordinates, I'm dividing a coordinate by itself, and so I get 1. So tangent of pi over 4 is 1, right there. But this is negative pi over 4. That's dipping down pi over 4 clockwise into the fourth quadrant, where our y values are negative. So if I have a negative divided by a positive, I'm going to get negative. So something negative divided by its positive self is going to give me negative 1. be careful there. There's kind of a misunderstanding, like it's not a negative output because this input was negative, which is kind of hard to understand there. This is a direction for our angle there and dipping into the fourth quadrant. So this value is negative because of the quadrant in which the angle is lying in. Tangent of 0, again, hopefully we don't need a calculator, but you can check it there. Tan of 0 is right here. 0 radians or 0 degrees gives me a coordinate of 1, 0. Y value is 0. X value is 1. 0 divided by 1 gives us 0. You may be able to guess that what's going to happen on the other side of our table here is where values are going to repeat. We do still have a periodic function, so values are going to repeat, but this time they're going to repeat in a positive fashion. So now we're climbing back up, getting really steep as we approach pi over 2, and then once we actually get to pi over 2, again, our function is undefined. So looking at this table, maybe you can visualize what our graph is doing. As I move left on the x-axis, my y values are dropping farther and farther down. As I move right on the x-axis, my y values are moving up and up and up until I reach an undefined value. So here's our tangent graph. You can look at this on your graphing calculator, although the website Desmos has a nice way of presenting graphs in general, and especially trig graphs. There are algebraic ways that you can work with tangent. You can find your vertical asymptotes using the equation pi over 2b. Real quick, let me go back up. The period length would be pi, and if we involve stretches of any kind or shifts, that changes to pi over b. So we found our period with sine and cosine by doing 2 pi over b. Now our period length is just pi for tangent, so our period is going to be pi over b. Half of that, half of your period, is going to tell you where your vertical asymptotes are. So pi over 2b is half of pi over b. There's an algebraic way to do it. So if we have tangent of x, our b value is just 1. So pi over 2 is going to be where the positive asymptote is. There's a negative version reflected on the other side. So you always just do pi over 2b and make it positive and negative, and that'll tell you where your asymptotes are. Again, just taking half of your period is a good way of thinking about it as well. So now on our graph, we can plot our asymptotes using our dashed lines there. We know that tan of 0 is 0, so we can put that point on there. We said that pi over 4 was 1. That's an easy thing to put on our graph. And negative pi over 4 is negative 1, another easy point to plot. Those points are sometimes called midpoints, and you can also find those algebraically by, again, just taking half of your asymptote value. So if I take half of that, I get to my halfway point. So half of a half is going to be a quarter, so our equation is pi over 4b instead. So we have pi over b for the period, pi over 2b for vertical asymptotes, and pi over 4b for our midpoint x values. To get the y values of your midpoints, it's just the amplitude value. So again, our tangent amplitude in its most basic form is just 1, that value in front of your trig function. So our b value is 1, so pi over 4 is our x value. That's what we said. And 1 being our amplitude, well, there's that coordinate that we already plotted. And we got the negative version of it reflected on the left side. All we got to do now is understand this behavior of our tangent graph, connect the dots. We're going to increase as we move right on the x-axis and get steeper and steeper as we approach the asymptote. We're going to go down as we move left on our x-axis and get steeper and steeper as we approach the left asymptote. So for us in our class right now, we're not going to make it any harder than that. So we can use these equations. We're not going to be shifting at all with our tangent graphs. So let's do a couple examples. Again, the asymptotes are one of the most important things. We got to identify where those asymptotes are. We can use those midpoint values if you want to remind yourself about the behavior of the graph. We can talk about the period length and make sure that it matches what it should be. So here we have a different tangent function. This time is tangent of x over 2, or tangent 1/2 x is another way to rewrite that. Move that fraction out to the front. So that's our b value, that 1/2. So our period can be found by taking pi over b. So pi over 1/2 is going to be equal to pi times 2, just multiplying by the reciprocal instead of dividing. So our period length is 2 pi. We've stretched the period of our graph, made it a little wider. Our vertical asymptotes are going to be at half the period. So if our period is 2 pi, half of that is going to be pi. And we can do the positive and negative version for the right asymptote and left asymptote. So now I know where to put my asymptotes. I can just count 2 spots to the right of 0 and 2 spots to the left and put my right and left asymptotes there. You could use that equation pi over 2b to get that as well. b being 1/2, 2 times 1/2 is 1, so pi is your vertical asymptote. Make sure you put it on the right and the left side. Our midpoints, if we want to find them, again, are going to be half of that, half of our asymptotes, or a quarter of our period. So pi over 4b, again, b being 1/2, half of 4 is 2, so pi over 2. Both the positive and the negative version will be our x values for our midpoints. Our y values for those midpoints are just the amplitude value, positive and negative versions. Amplitude here is 1, so there's our y coordinates. So at pi over 2, 1 is a midpoint, and at negative pi over 2, negative 1 is another midpoint on the other side. So that lets you know that from 0, it's going to go up on the right side towards that asymptote, and on the left side, it's going to be going down as it approaches that asymptote. You can see our period interval from one asymptote to the other was negative pi to pi. That is a length of 2 pi. Here's 1 pi there. Here's another pi. So that matches with our period length. And there's the graph of that tangent function. One more time, you can pause the video and do this next one on your own and then check it, or just watch as I talk our way through it again. Given this function, pi over b is going to give us our period length. In this case, b is pi, so pi divided by pi is 1. Our period length is going to be 1 unit. Important to establish where those vertical asymptotes are. It's going to be half of your period. Half of 1 is 1/2. Let's make sure we make it positive and negative for the right and left asymptotes. Or you can use your equation pi over 2b. In that case, the pi's cancel and we're left with 1/2. At that point, if you don't need those midpoints, you know the behavior of the graph, well then you can go ahead and graph that tangent curve. Otherwise, finding the midpoints again is just going to be a quarter of our period, or half of what we said the vertical asymptotes were at. Half of 1/2 is 1/4, or you could take a quarter of 1, which is 1/4. The a value or the y value, both are the same, is 2 in this function. So at negative 1/4, negative 2 is going to be a midpoint, and at 1/4, positive 2 is our other midpoint. Connect those points, making it steeper as it approaches the right asymptote, going down, making it steeper as it approaches the left asymptote, gives you this tangent curve. That period interval from left asymptote to right asymptote was negative 1/2 to positive 1/2, which is a length of 1. All right, so there's the graph of that tangent function. So in our class, it's not going to be any more difficult than that when we're sketching tangent by hand, although of course it is possible for tangent functions to have horizontal or vertical shifts. We're just not going to focus on that in this class at this time. So good luck practicing those types of tangent functions. And if you care, take a look at the next video where we're going to talk about the reciprocal functions as well.